For example, suppose we want to take these derivatives. This first function we want to take the derivative of is 7 times e to the x minus 3x to the 5. So the first thing we're going to do is we're going to use the difference rule to split up these two separate functions. I'm going to take the derivative of 7e to the x, and then I'm going to subtract the derivative of 3x to the 5. Then I'm going to use the constant multiple rule. The derivative of 7e to the x is 7 times the derivative of e to the x. The derivative of 3x to the 5 is 3 times the derivative of x to the 5. Then I can take the derivative of each. The derivative of e to the x is just e to the x. The derivative of x to the 5 is 5x to the 4th. And I simplify to get 7e to the x minus 15x to the 4th. This next example is a little bit more complicated. The reason is because I've got this 2 on the bottom of a fraction. So before I can take the derivative, I need to simplify. Well, I can divide each thing separately by the bottom of the fraction. I'm going to get e to the x over 2 plus 2 over 2. The e to the x over 2 I can rewrite as 1/2 times e to the x. The 2 over 2 just gives me 1. So now that the function's rewritten, I can take the derivative using the sum and constant multiple rules. So first, the sum rule says I can take the derivative of 1/2 e to the x and 1 separately. Take the derivative of 1/2 e to the x, I first use the constant multiple rule to write the 1/2 in front, and then I got to take the derivative of e to the x. 1 I'm going to think of as x to the 0 when I'm taking the derivative. The derivative of e to the x is just e to the x, so the derivative of the first thing is just 1/2 e to the x. The derivative of x to the 0 is 0. So 1/2 e to the x plus 0 is just 1/2 e to the x. This last function, g of x, is sometimes confusing for people because of this function x to the e here. The key thing about x to the e is when we're taking its derivative, we're not going to use the e to the x rule, we're going to use the power rule. And the reason for this is because we use the power rule whenever we have an x in the base and a number in the exponent, a constant in the exponent. If we have a constant in the base and an x in the exponent, then we use the exponential rule. So when I take the derivative, first I'm going to say, okay, I can take the derivative of e to the x and x to the e separately. When I take the derivative of e to the x, it just gives me e to the x. When I take the derivative of x to the e, I write the exponent in front and subtract 1 from the exponent to get e times x to the e minus 1.